Hello friends, welcome to Bhavesarki online class. Hello friends, you invited me over a cup of coffee at your place. You asked me, sir, how much coffee you'll have? I asked, I'll have light coffee, I'll have only half spoon of coffee powder. Now, very interesting thing to know. You can just see this three size of spoons over here. Now when I said half spoon of coffee or a 1 spoon of coffee, which spoon you'll pick up? This one or this one? It is up to you which to pick up. But if you pick up this much and if you pour coffee powder in my coffee, it will be not drinkable by me. Question arises, sir, what are you trying to explain us? Now my point over here is very simple, my dear friends. When you want to measure something, here we were measuring coffee powder, you need to have some standard process for measuring that particular thing. And our today's topic is measurements and experiments of physics. Today we are going to see measurement part, and later on we shall see experimentation part also. Today's lecture we shall restrict ourselves with the measurements. Measurement is the process of comparison of the given physical quantities with the known standard quantity of the same nature. Standard quantity of the same nature. Why did this word standard comes into play? I hope you will understand this with the example which I give, which spoon you will use it. So whenever you want to do some measurement, and if I say something 1 teaspoonful of or something like that, there should be something standard over here. So for measurement, first of all, you should know the definition of the measurement, right? And for measuring, there is a quantity. Like just now you asked me coffee powder. So coffee powder was the object which was to be measured. And in physics, whatever we are measuring is called as a quantity. Say for example, you want to stitch your uniform. You may ask, I want 2 meters of cloth for my shirt. So you are measuring length over here. So length is one of the quantity. Likewise, you know mass, you know time. Likewise, you can list down so many quantities. Every quantity, when you measure, it has two components. One, its quantity means its numerical value, and its unit. Now I will take this example again. 2 meter, out of 2 meter, 2 is the numerical value and meter is the unit. So whenever you want to measure a quantity, it is measured in two components, the numerical value and the unit. So if I say I am having 2 liters of milk, so I am measuring milk, but which quantity I am measuring here is called as a volume. Volume is the quantity which I am measuring, fine, and it has, as we discussed just now, it has two components, the numerical value 2 and liter as a unit. Now very interesting thing to know is you have to choose the correct units for your measurements. Like here you ask for 2 meters of cloth. Suppose I am measuring the distance between two cities, then I will not call it as in meters, I'll be calling it into kilometers, fine. So choice of unit should be very proper. The unit should be of a convenient size. As I told you, if you are asking this in centimeters, it is not a convenient size. It should be possible to define the unit without any ambiguity. Ambiguity means it should be universally remain same. That unit should be again and again reusable or reproducible across the world, as well as the value of this particular unit should never change with space and time. What I mean to say, suppose 2 meters if I am measuring today, and somebody might have measured 2 meter 2 years back, or 10 years back, or 100 years back. It should not change with the time as well as the space. Space here means one place to another place. So these are the very important points for choice of unit. We have understood what is measurement, we have understood what is quantity, and every quantity has to be measured with a convenient unit, and you have to choose the unit very carefully. Like here I'm just giving one more example choice of, while you are choosing the unit, here I say 2 liter of milk. Instead of milk, suppose if you are buying sanitizer, then you may not buy in liters. If you see that particular bottle, that bottle will have something written down as 50 ml, 100 ml or something like that, ml, milliliters. So the sanitizer, which is little costlier and we cannot carry in large quantities, will be in a smaller unit. So that is called as a choice of units. Dear friends, we understood units. Now these units can be divided into two groups. One is called as a fundamental unit, and other is called as a derived unit. Now what is the difference between fundamental unit and derived unit? Fundamental means basic, very simple, basic unit. It will never change with time, with space. It does not depend on any other unit. So that is independent of any other unit, is called as a fundamental unit. Say for example, when I am measuring distance, I will be measuring in meters. If I am measuring in time, I will be measuring in seconds. So this meter, second, these are the units, and of course there are a few more units which are fundamental units. Whereas you might have studied the topic of volume, where volume will be measured as meter cube, area will be measured as meter square. Now this meter cube is dependent on three distances, meter into meter into meter. This is meter into meter. Fine. If you know density is kilogram per meter cube. So it is dependent on kilogram, it is dependent on meter, meter and meter. That is three distances it is dependent on, and it is dependent on mass. So units can be divided into two categories. One is called as a fundamental unit, other is called as a derived unit. Having said that, we have to understand in how many systems these units are calculated. Now long back, when there were no many systems into prevalent and Britain was almost ruling over the entire world, that time the three fundamental units are distance. Those are the basic fundamental units: distance, mass and time. These were the three basic fundamental units discovered at the start of the physics: distance, mass and time. Using these three basic things, the system was divided by Britishers. It was called as a FPS system, where F is a foot, a unit of measurement of distance. Pound was a mass, a measuring mass, and second was measuring time. This system was prevalent when Britishers were almost ruling the entire world, but slowly it was not a very convenient method of measuring the things. Then came into existence two more systems, which is one is called as the MK system, and other is called as a CGS system. Now this is something very interesting. Whenever some system is named, these three older systems are there, they are labeled as, you see, F, that is foot for distance, here meter for distance, here centimeter for distance. Second one, here I've written mass, so pound, kilogram, gram. Time I've written second. In all these three systems, the time was measured in seconds, but the mass and distances were measured in different units. Later on, more fundamental quantities were discovered, and it was found that the systems whichever are prevalent are not adequate to go for the universal acceptance. So there was a new system which is prevalent now, and we use it internationally. It is called as a standard international. It came into existence around 1960. Fine. And length, mass, time, temperature, luminous intensity, electric current, amount of substance, angle, solid angles, this many quantities, that is 6 and 3, 9 quantities were considered as a fundamental quantities in standard international in around 1960. And then from that onwards, we are using the same system throughout the world. Dear friends, at times we have to calculate the measurements in a bigger unit or smaller units. If you are talking about microorganisms, it may be in 0.00005 meter or something like that. If you are measuring your memory of your mobile, then it may go to in GBs, gigabyte, you may be knowing it, fine. If your laptop is there, PC is there, it may be terabyte. Your files, WhatsApp files, etc. may be in megabytes, etc. So we are going to understand the metric system. And what is this metric system? Metric system has total 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore, as it is considering those 10 digits, the system is called as a metric system. So whenever you come across a metric system, you have to understand you are going to use in all 10 digits. There is another system also called as a binary system, which is used by your phone or computer, etc. Whatever software is there, it is used by binary system. And this binary system is not a part of your syllabus, your scope, but this is for your additional information. It is using only 2 digits, 0 and 1, and hence it is binary system. So coming to metric system, my dear friends, as I told you, it contains 10. Now, if the units are 10 or more than 10, then there are few prefixes. And remember, any prefix, when you are using it, it should start with a small letter. Here, I made an error. I'm changing it. Yeah. Now, these are the units, metric system, 10 or more than that. If I say deca system, if I use the word deca as a prefix, then 10 raised to 1. If I use hecto, it means 10 raised to 2. If I use kilo, it is 10 raised to 3. Something interesting now. If I talk about mega, then it is 10 raised to 6. If I talk about giga, then it will be 10 raised to 9. Tera, 10 raised to 12. Peta, 12 raised to 15. Exa, 10 raised to 18. Zeta is 10 raised to 21. There is one more bigger unit you called as iota, 10 raised to 24. So these are the prefixes. If your number is going too high, suppose that it is something like this, say for example 2 1 2 के बाद 3 4 5 6 zeros, something like this meter, fine. So instead of writing this as 20 lakh meter, physics will suggest you, instead of writing this, I'll be writing down 2 into 10 raised to 6 meters. This is the value of this particular thing. Instead of writing that, I'll be writing as 2 megameters. I hope you understand this. What is used here is megameters, fine, because it was 2 lakh meters. So instead of writing 2 into 10 raised to 6 meters, it is written as 2 megameters. You might have heard the power is measured in kilowatt. If you see your appliances like refrigerator, etc., they use kilowatt. So that is kilowatt. That means so many watts divided by 1000 will give you kilowatts. So these are the units which are bigger than 10, either 10 or more than 10, up to 24 power, 10 raised to 24 power. Physics have defined. Of course, more than that also can be defined, but it will be little cumbersome to know that particular thing. And smaller units, you are measuring viruses, etc., then this goes as 10 raised to negative 1, that is 0.1, 10 raised to negative 2, 10 raised to negative 3. You may be knowing this particular thing. Milliliter, 1000 part of a liter, milliliter, fine. You are knowing centimeter, hundredth part of the meter, that is called as a centimeter. Micrometer will go as 10 raised to negative 6. Nanocar, you must be knowing it. It is a 0.0009 times 0, so many meters. It is called as a nano. Of course, nanocar was of not this size, but it was smaller in size. It was named as nanocar. Picometer measures up to 10 raised to negative 12. Femtometer measures up to 10 raised to negative 15. Atto measures 10 raised to negative 18. Zepto will measure 10 raised to negative 21. And Yotto will measure 10 raised to negative 24. That is a metric system you should know, and these are the things which are used as prefixes. Instead of writing the bigger numbers, you just write down 2 mega a meter or something like that. Like, you know, as I told you, suppose your machine works as 4000 volts. So instead of writing 4000 volts, we will write down 4000 kilovolts. What is the unit of power? Next subtopic is about the length. You should learn the definition of length, which is little lengthier, my dear friends. I don't think so they will ask the definition of length in board examination, but still if you want to don't want to take any risk, you will study the definition of length. Unit of length, that is SI unit of length, is meter. Just now a few minutes back we discussed. Then we have to understand the subunits. Subunits means smaller units. We measure sometimes units small in the smaller part also. So centimeter is one of the subunit, which is 10 raised to negative 2 meters. If it is millimeter, then it is 10 raised to negative 3 part. Micrometer, which is often known as micron, my dear friends. When you buy some articles and if you carry a plastic bag, then on plastic bag there will be might be written down as micron. So micron, again a distance which is measuring up to 10 raised to negative 6 meters, and nanometer we discussed is 10 raised to negative 9 meters. Multiple units, generally very rarely we use the very big units. We in day-to-day life we use kilometer, which is 10 raised to 3, that is 1000 meters makes 1 kilometer. My dear friends, there are few smaller units which I've written some certain things in green, red. Green and red are the standard units which are following metric system. This two colored one are following metric system. This black one are not following metric system. It is 1 Armstrong unit, which was earlier, you know, it was measured, and it is 10 raised to negative 10 meters. And Fermi was another unit earlier used, which is 10 raised to negative 15 meter. My dear friends, distance between Sun and Earth is known as a 1 astronomical unit, which is in short written down as AU, and that particular distance is 1.496 into 10 raised to 11 meters. My dear friends, you do remember all these values. I'm sorry, but you will need to remember this. I know it may be a little tougher for you. Light year, and when we hear this part, light is fine. When we hear this part here, हमको दिमाग में ऐसा लगने लगता है कि we are measuring the time. And my dear friend, this is light year is not a measurement of time, it is a measurement of length. Sir, year आ गया तो length कैसे measure करेंगे? And year is not only year, it is light year. Light year means distance traveled by a ray of light in 1 year. It is called as a light year. And I don't know what is the speed of light right away. I can tell you, but definitely you'll try to find it out. But a light ray is the fastest traveling on this earth known till now. Fine. And if ray is started from here, after 1 year, it will be covering around 9.46 into 10 raised to 12 kilometers. So many kilometers it will travel in a year. And remember, there is one more unit, parsec unit, and this is nothing else but 3.26 times a light year. Fine. So dear friends, this is about length. We shall move to another unit of length we did. Now we will do unit of mass, which is another basic quantity. Next two fundamental quantities are mass and time. SI unit for mass is kilogram and its subunits are gram and milligram, and I've written in green color its a subunit in the terms of metric system 10 raised to negative 3, and this will be 10 raised to negative 6. Sometimes when you measure the bigger units of mass, they are measured in quintals, and quintal is nothing else but 100 kg, but we generally do not represent it as kg, 100 kg. We write it down as 10 raised to 2. That is 10 raised to 2 kg will be equal to quintal, as well as metric ton you come across, that is 10 raised to 3, that is 1000 kg will make metric ton. There are smaller units you might be studying in chemistry, that mass of an object, or not object, I'm sorry, mass of an atom is approximately equal to 1.66 into 10 raised to negative 27 kilogram. Instead of writing this much, if I write down 1 AMU, that means mass of that particular atom is 1.66 into 10 raised to negative 27 kilogram. Fine, so much smaller. Negative 27 means 0.00027 times, then 166. Fine, so that is the so small unit of mass of an atom is there. And nowadays this AMU, in honor of John Dalton, you must be studying John Dalton in chemistry, it is represented using a symbol U, which is called as a Dalton. So 1 Dalton is 1.66 into 10 raised to negative 27 kilogram. Sometimes very big units, when we are talking about the celestial bodies, they are measured in terms of solar mass, and solar mass is nothing else but mass of sun is approximately 2 into 10 raised to 30 kilogram, dear friends. It's so heavy. Next quantity which we are going to talk about is time. Time is measured in seconds. Its subunits may be millisecond, you might have heard millisecond, as well as microsecond. Millisecond will be 10 raised to negative 3, and microsecond 10 raised to negative 6. And measurement of bigger units of measuring time are like you may be knowing in minutes, hours, days, month, year, decade, century, millennium, etc., 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 which you are very much familiar with it. So I'm not going into much details of bigger units of time. Dear friends, we shall see the last part of section A, guidelines for writing units. A few minutes back we saw that some of the units, like unit for measuring atoms, atomic mass unit, is now named after the great scientist John Dalton. Same way, force is measured in terms of Newton. So certain units are named after scientists and many units are not named after scientists. So what guidelines we have to follow, that we will try to understand. I have categorically divided units into two parts: named after scientists and named after not named after scientists and named after scientists. So for example, if I'm measuring length in meters and I want to write down into abbreviation as meter, then I'll write it down small m. Then suppose I want to write it down liter, then I'll be writing down small l. So whenever a unit is used in abbreviation and it is not named after a scientist, we use the smaller letters. If I'm using a scientist name, say for example I'm measuring force, then and I'm using abbreviation, then it is written as capital N. So whenever a unit is named after a scientist and you're using abbreviation, then you will write it down capital letter. Now, whether named after scientist or not after scientist, you're writing the full unit like meter. Fine. Newton. Now you will stop me, sir. Apne pehla letter, it's a proper noun. You should write capital N, my dear friends. I'm not teaching you English. If you are right with the English rule, but if you are writing any unit in full form, whether it is named after a scientist or not named after a scientist, whatever it may be, if you are writing in full form, then first letter by default will be small letter. Now, what are compound units? Next part we have to understand compound units. Unit obtained by multiplying or dividing two or more quantities. Say for example, if you are measuring, I'm talking about torque, moment of force. Last year you studied. It is written down as Newton meter. Dot means multiplication. And here I made it capital because I'm using the abbreviation. I'm following this rule. Here abbreviation meter, I'm writing down as Newton meter. Fine. This was when we talk about the product. If it is in the form of a division, say for example, I'm talking about speed, then speed I will be writing down as actually meter upon second, which will be in physics it will be written down meter into s raised to -1. In maths you may see this as meter per second, kilometer per hour. But if it is something like this in physics to be written down, then you cannot write down this way. You have to write down it as a negative power. So these are the 5 rules we should know. Sixth rule we should know as whenever we are writing any abbreviation, say for example you are writing 100 meters. This is I've written in full form. I've written the plural form of meters as by applying s over there. This is perfectly right. But this 100 meters I cannot write down 100 ms. If I am using plural form in abbreviation, it is wrong. The correct way to represent 100 meters in abbreviation is 100 meter. So that was the 6th rule, that the abbreviation whenever you are using, you cannot use the plural form as s or es. You know, English rule does not apply over here. Next rule, 7th rule, is about writing the bigger unit. Say for example, I am having 10 raised to 3 meters. Instead of writing 10 raised to 3 meters, I can avoid using this power. Directly I can write down 1 kilometer. Or if I am having 10 raised to 6 meters, I can write down 1 megameter. That is instead of writing the power, I have used here prefix. Here also I have used as a prefix. And remember, if you are using any prefix, then you cannot write down two prefixes together. You cannot write down 10 kilo, mega, like this. Two prefixes cannot be allowed together. That's all from this session. Thank you.